Assalamualaikum and good day. Today I will be presenting the first question, which is explain the meaning of differentiation and what are the techniques of differentiation. So, what is differentiation? Differentiation is a concept of calculus that tells you how fast something is changing at a particular point. Why do we use differentiation? First, we need to use differentiation to find maximum and minimum values. How can differentiation help us find maximum and minimum values? Well, differentiation helps us identify the highest and lowest point on a curve. This is important for optimization problems like finding maximum profits, minimum cost, or most efficient design. Secondly, differentiation helps us understand how graphs behave. Differentiation helps us to see whether the graph is increasing, decreasing, or staying constant at any point. By looking at the derivative, we can tell the shape of the graph, how steep it is, and where it changes direction. Third, it helps us find the rate of change. Many things in real life doesn't stay the same. They change over time. Differentiation helps us measure how fast they change. For examples, it tells us how quickly distances speed, how fast population grows, or how fast a chemical reaction rate increase or decrease. It helps us solve motion problems. In physics, differentiation connects displacement, velocity, and acceleration. It allows us to find how fast an object is moving and how its speed changes with time. Fifth, it helps us calculate slope at any point on a curve. How does it help us? Well, a straight line has a constant slope, but a curve doesn't. Differentiation gives us the exact gradient at any position on the curve, so we can understand how steep it is at that moment. That is all I can explain about differentiation. Next, we will be moving on to the technique of differentiation. It consists of 12 techniques, which is first, power rule, second, constant rule, third, constant multiple rule, fourth, sum rule, fifth, difference rule, sixth, product rule, 7, chain rule, 8, exponential function rule, 9, logarithm rule, 10, quotient rule, 11, trigonometric derivative, and 12, inverse trigonometric derivative. Next, I will explain shortly about how the techniques are being used and give us some easy example for you to understand more deeper. First is power rule. What it does, it is used to differentiate x power n, any power of x. The formula is like being given. For example, you got a question, y equals x power 5. When we differentiate it, the power 5 will be brought to the front and then the power will minus with 1. Therefore, the final answer will be 5x power 4. Next is constant rule. What it does, constant number never change, so it is derivative equal to 0. The formula is like that. Example question is D. When we differentiate 12, it equals to 0. Next technique is constant multiple rule. What it does, if a function is multiplied by a number, just differentiate the function and keep the number, just like the formula given. For example, question, y equals to 4x power 2. When we solve it, we differentiate. We write 4 first, then we differentiate x power 2, that become 2x, and then we solve it. Just 4 multiplied by 2 equals 8x. That is the final answer for that question. Next is sum rule. What it does, if you add function, differentiate the function separately and add. The formula is like being given on the slide. For the example question, when you got question, for example, y equals to 3x power 2 plus 5x, you have to differentiate the first function, which is 3x power 2 becomes 6x. Then we differentiate the 5x, which is 5. The final answer will be 6x plus 5. Next is difference rule. When it is used, it is similar to sum rules but subtraction. Like the formula given, like sum rule, it is plus, but in difference rule, the symbol is minus. So the final answer will be 6x minus 5. We will move on to the sixth technique, which is product rule. When to use product rule? We use product rule when two functions are multiplied but with each other. Like the formula being given, when you got question, for example, question given, we have to differentiate the two functions first, which is for the fx function, we got x, and for the gx, we got 3x power 2. When we differentiate both of that function, we will get 1 for function fx and 6x for function gx. Then we apply then we just add it onto the formula. Then when we solve it, we will get the final answer is 9x power 2. Next is quotient rule. When to use this rule? When we use this rule, when the function is in the form f per g. Formula is being given on the slide. For example, we use the same question for the sum rule. We differentiate the two functions first, then we apply onto the formula that been given. Then we solve it. We got negative 1 per 3x power 2. Next is chain rule. When we to use chain rule? When we use chain rule when a function is inside another function. Formula is like being given on the slide, meaning differentiate the outside first and keep the inside same, then multiply by derivative inside. For example, question being given, y equals 3x plus 2 power 4. We have to differentiate the power first, so the final answer will be the answer for differentiation of power 4 is 4u power 3. We differentiate it the same as we use power rule. Then we differentiate the inside, which is 3x plus 2, which is the answer will be 3. Then we apply the chain rule with the differentiation answer, and when we solve it, we will get 12 3x plus 2 power 3. The ninth rule is exponential rule. The formula is being given. For e power x, the derivative is the same because the exponential functions grows at a rate exactly equals to its own value. Next is logarithm rule. The formula is like on the slide. For example, when you get a question, y is equal 5 in x. So when we solve it, we already know that on the formula the ln x will be 1 per x. So when we write the answer, we write that first, then we only separate the 5. Then we multiply it together to get the answer, the final answer, which is 5 per x. Next is trigonometric derivative formula. The formula is being given on the slide. Like, it has 6 formula which we can apply with different question that can be referred with the formula. For example, I take formula number 1, which is d per dx since x equals to cos x. When you got the question y equals to 5 since x, the final answer will be 5 cos x. The 12th technique is inverse trigonometric derivative. It has its own formula too, and it has many formula for each question that you can refer onto the formula when to use it. And for the example question, for example, I take the formula for number 1 question. When you got y equals to arc since 2x, step number 1 is use chain rule to differentiate it. Then when we solve it, the final answer will be 2 per square root 1 minus 1 negative 4x power 2. That's all from...
Hi everyone. Today I will present question 3, which is about finding dy over dx for two given functions. Part A, the function is y equals e to the power of negative 2x multiplied by bracket 3x plus 1 bracket. We can see that this is a product of two functions, so we can use the product rule. The product rule formula is the derivative of uv is equal to u prime times v plus u times v prime. Step 1, let u be e to the power of negative 2x and v be 3x plus 1. Step 2, find u prime and v prime. U prime equals negative 2e to the power of negative 3x. Meanwhile, v prime equals 3. Step 3, apply product rule. dy over dx equals negative 2e to the power of negative 2x times bracket 3x plus 1 bracket plus e to the power of negative 2x times 3. Next, we factor out the e to the power of 2x. dy over dx is equal to e to the power of negative 2x bracket negative 2 bracket 3x plus 1 close the bracket plus 3. After that, we simplify inside the bracket. dy over dx equals to e to the power of negative 2x bracket negative 6x minus 2 plus 3. So the final answer is we get dy over dx is equal to e to the power of negative 2x bracket negative 6x plus 1 close the bracket. Next question. Part B. Y equals square root of x plus sine of 3x. We can differentiate term by term. Step 1. Square root of x is equal to x to the power of 1/2. The derivative of x to the power of 1/2 is 1 over 2 to the power of negative 1/2. After that, we can simplify, which is 1 over 2 square root x. Step 2. Derivative the sine 3x. By using this formula, the derivative of sine 3x is 3 cosine 3x. So the final answer is dy over dx equals 1 over 2 square root x plus 3 cosine of 3x. That's all from me. Thank you.
Hi, my name is Noalia Zahra. Today I'm going to explain about question 3. Given e power of 2y plus 2x equals y power of 3 plus cos 4x, find dy over dx using implicit differentiation. First, we need to apply the derivative operator d over dx to every term on both sides. the equation. Remember that whenever we differentiate a terms involving y, we must multiply the result by dy over dx, the chain rule. So for example, d over dx, e power of 2y plus 2x equals d over dx, y power of 3 plus cos 4x. First, calculate the derivative of each terms. Derivative of e power 2y using the chain rule, d over dx, e power of 2y equals e power 2y multiply d over dx 2y, you will get 2e power of 2y dy over dx. Derivative of 2x, d over dx 2x, you will get 2. Derivative of y power of 3 using the chain rule, d over dx y power of 3 equals 3y power of 2 dy over dx. The derivative for cos 4x using the chain rule, d over dx cos 4x, you will get negative sine 4x multiplied by d over dx 4x, you will get negative 4 sine 4x. Substituting this derivative back into the differentiated equation, 2e power of 2y dy over dx plus 2 equals 3y power of 2 dy over dx negative 4 sine 4x. Isolate terms containing dy over dx. We want to gather all terms with dy over dx on the one side. For example, like we will put in the left side, and all other terms on the opposite side, the right side. So for example, 2 over 2e power of 2y dy over dx negative 3y power of 2 dy over dx plus 2 equals negative 4 sine 4x. Subtract 2 from both sides. 2e power of 2y dy over dx negative 3y power of 2 dy over dx equals negative 4 sine 4x negative 2. Step 4. Solve for dy over dx. Factor out dy over dx from the term on the left side. For example, 2e power of 2y negative 3y power of 2 dy over dx equal negative 4 sine 4x negative 2. Divide both sides by the factor 2e power of 2y negative 3 power of 2 to solve for dy over dx. For example, dy over dx equals negative 4 sine 4x negative 2 divided by 2e power of 2y negative 3y over power negative 3y power of 2. We can factor out negative 2 from the numerator to present the answer slightly cleaner. Dy over dx equals negative 2 sine 4x plus 1 divided by 2e power of 2y negative 3y power of 2. So the derivative is dy over dx equals negative 4 sine 4x negative 2 divided by 2e power of 2y negative 3y power of 2.
Alright, now it's my turn to present question 4. This one is all about 2.7 linear approximations and differentiations, and I will break it down in a simple way so it's easy to understand. So the question given here, question 4, use linear approximation to estimate the value of 1 over cube root 124.99 plus cube root 124.99 square. Incorrect to 3 decimal places. So firstly, for x1, we're going to use the value that already given in equations, which this one 124.99. So we put it here, 124.99. For x0, I'm going to choose a nearby value that is easy to work with. For me, I will choose 1 to 5. I choose 1 to 5 as a nearby value because 1 125 equal to 5 cube. So it's easy for so it's cube root, so it's simple, it's going to be simple. And then we will find the change in x, which is we need to use this formula, x1 minus x0. So as we can see here, 124.99 minus 125, we got the answer minus 0.01. And then so now we need to define the function. So the function here, I replace this value to x, and I define the function. I define the function until I got x minus 1/3 plus x 2/3. And then thirdly, we will differentiate the function that already given here, that we already defined. We need to differentiate it, so we got f prime. So f prime here, I got the answer minus 1/3 x minus 4/3 plus 2/3 x minus 1/3, as we can see here. So now we can use this formula to substitute the values. So the formula was already given here, so we just need to enter the value in this formula. So as we can see, we put 124.99 here because it was x1, and I put 125 here because it's x0. So we enter the number in the formula. As we can see here, I put it here for fx1, and then I put fx0, I replace it with this one. I use these equations, and then plus f prime x0. So f prime x0, this one, I use this one. I use these equations, and then we have value of x. So value of x here that we already find first, this one minus 0.01. So we put it here. Now we by using the calculator, we found the answer to 3 decimal places. We need to give 3 decimal places because it's already in question, so we need to give 3 decimal places, and I got the answer 25.199. That's all from me. Bye.